This is lab 11, MO7, Chelsea Sizemore. In this lab, the main objective was to identify constant velocity, and the result was to analyze the data to prove constant velocity. For my data, I tracked myself on a golf cart. Here is a video of me driving a golf cart, and I tracked this video in Tracker. The time clip is about 1 second, and I started the clip right as I started the golf cart, and I ended the clip right before I stopped the golf cart. So this video is always in constant motion. I put the axes in the positive X direction as the way I'm driving, and when I press play to see this, you can see that the line is a straight line showing constant velocity of the golf cart. I use the initial position of the golf cart, which
I got from the analysis of the first frame of the video. The average velocity I estimated by taking delta x over the entire video clip. That is the final position minus the initial position, and divided that by the total time of the video clip, which is about 1 second. That gave me the estimate of the initial velocity. Lastly, I chose delta t to be small compared to the 1 second time elapsed of 0.01 seconds. So I predicted for starting at time for about 2 seconds and applied Newton's second law. So the final velocity and constant velocity will be equal to the initial velocity, which means the second term, F net over m delta t, has to be equal to 0. The only way for that to happen is to have F net equal to 0. I set F net equal to 0 in the model and then used that to predict the motion based on the given initial condition and system mass. Notice that the system mass doesn't come into play because if the F net is 0, then the mass does not matter.
Here is a visualization of the golf cart moving in the X direction. Well, let me start over. The best way to show the two different datas is to graph it on Excel, and because I'm technologically challenged and can't speak English, I couldn't put it on one graph, but you can see that the graphs are very similar, and the red one on the right is from Tracker, and the blue line on the left is from Python, and Python is a little bit straighter, but it is very similar, showing constant velocity in both the experiment and the actual data.